Hey guys, so today's video is about vectors, right? So this video is for students, mostly for students who are taking undergraduate level physics. So let's see what are vectors, and when vectors are introduced, we obviously talk about scalars also. So vectors are quantities that have both magnitude and direction, okay? And scalars are quantities that have only magnitude, okay? So scalars have only magnitude. So magnitude, by magnitude we mean, just a number, right? So an example of scalars are temperature, and length of an object, length of a ruler, length of a table, or whatever. So length is also a scalar quantity, okay? Another example is speed, okay? That's also a scalar quantity in physics. So example of vectors include velocity, displacement, force. Okay, so these are example of vector quantities. Now whenever I introduce vectors in my classes, I get this question: why do we introduce vectors? Why do we need vectors? Right. So let's start with the motivation. Okay. So let's say that you are playing. Okay. And you throw a ball. Let's say you're standing over here. Okay. And then you're having fun. You throw a ball. Okay, I want to sort of like make you throw the ball where the origin is. So let's start over here. Let's say you kick the ball. That's better, right? So then, there you go. The ball goes on a parabola and hits the ground. So let's we call this your x-axis and it's your y-axis. Okay. So now, if someone asks you where the ball is, you'll obviously point towards the ball. So you're essentially pointing towards the position vector of the ball. So let's say the ball is over here. So you'll say, oh, here's the ball. And you'll point towards the position vector. Okay. So then you can obviously, so when the ball is over here, the position vector is this one over here, right? Now, in order to study the motion of the ball, you would obviously need the length of this vector, right? And then you need this angle also that this vector points towards that the vector makes with the x-axis, right? So that's one way to analyze the motion of the ball. You need this length again and this angle, right? Now there's another way which makes life easier, is by looking at the projection, which is obviously connected to what I said over here, is by looking at the projection of this vector, right, with on the x-axis. So let's say you're shining, you're like using a flashlight over here, and there's a shadow over here. So that's the projection, right, of this position vector. So the length of the projection x is x over here, and the projection on the y-axis. So let's use green for that. So then this projection over here, so y-axis. So instead of looking at the length of the vector, you can start off with independently studying these projections, right? And then connecting this with the length of the position vector and this angle. So that's what vectors are. Vectors are sort of like advanced version of numbers, where you would look at these projections independently. Now the interesting thing is you can forget about the other one, and just look at, when you're looking at this one, you can forget about this one. When you're looking at this one, you can forget about this one. So it makes it easier. You're essentially like studying your motion on a straight line, on two straight lines, and bringing it together to extend it to 2 dimensions, right? So the way you would write, if you call this the position vector, the way you would write this position vector r, let's say, by saying x, that it's equal to xi hat plus y j hat. Okay, so they don't add together like numbers, right? So these are like independent directions, and um, and you can study these two independently and bring them together by using this equation, and the length of the vector, position vector, will be like x squared plus y squared, and the angle, if you want to call this theta, will be given by y divided by x. So that's a motivation. Let's formally, like, instead of using the position vector, let's use just a symbol to represent vectors. Okay, so that's what vectors are. Like, they enable us to study the motion of objects, or to study any quantity in 3D or 2D by just looking at the projection of the vector on the x and y axis, and then using these trigonometric relationship to study the magnitude and the angles, right? So let's say that you're in 2D, so this is your x-axis, this is your y-axis, right? Now let's say that you have a vector A. Okay. Now this is, let's call this component AX. So this is again your projection on the x-axis, this is AY, and this angle is theta. So how is this angle again connected with these two? It's or the magnitude, so it's they're connected through the trigonometric functions. So the sine of this angle is this divided by this. So sine theta is AY divided by A. Cosine theta is AX divided by A. And tangent theta. So cosine theta is this divided by this, and tangent theta is this divided by this. So you get tangent theta equals AY divided by AX. So the way students usually remember this is by the SOHCAHTOA, right? So this is opposite over hypotenuse. So this is adjacent over hypotenuse. This is opposite over adjacent. So this is SOHCAHTOA, right? That's a trick that students use. And the way you would write the vector A in terms of the components is again that same way. So A equals AXI hat. This is a subscript plus AY J hat, right? And the magnitude of A is given by square root of AX squared plus AY squared. So this is a 2D vector, right? 2D vector. Now let's I'll just draw a 3D vector. We're not going to go into details because for introductory level physics or undergraduate level physics, you don't usually go into the details of 3D vectors. But let's draw a 3D vector and see how the components are visualized in that case. So let's say you have 3D. So this is your like out of the page direction. So this is, let's say, your x-axis. This is your y-axis, and this is your z-axis, right? So let's say that here is your vector A, right? Now the projection of A on the xy plane, let's say this, right? And the projection of this projection on the x-axis is this. So this is your AX component. The projection of this line on the y-axis is your y component. So this is your AY. And the projection of this on the z-axis is your z component. Okay. And the way you would write this vector is A equals AXI hat plus AYJ hat plus AZ k hat. So in 3D we have this additional part where the k hat is usually used for 3D vectors. So some books would use x hat, y hat, and j hat also. So this is more common. I hat, j hat, k And angles in this case will be, you need of course an angle also to locate the vector. So this can be an angle and this can be an angle, theta and phi, let's say. So again, I'm not going to go into details. You can easily write again, use SOHCAHTOA for theta and phi to write trigonometric relationships for the components. That's an easy thing, but we will do that in more advanced videos. For undergraduate level physics, you don't go into these details usually. So, but of course, let's just write the magnitude. The magnitude is this. Okay. So this was a basic introduction to vectors in 2D and 3D. If you have any questions, post them in the comments, and if you like the video, please subscribe. Thank you for watching.